I'd like to introduce you to Chris Evenhuis, and we're going to listen to Chris talking about his science, and we're each going to listen in a different way because we're coming from very different disciplines in the arts, and the whole purpose of this program is to understand different ways of understanding the environment.
Sort of a facilitating kind of role where I work with lots of different people on parts of their project. So my background, I come from physics and maths, and then did some chemistry, and then sort of progressed through into our ecological kind of modelling and biology, which I'm doing now. So it's looking to bring together different approaches in science to predicting and understanding and seeing the impacts of the changing climate.
I'm working as a visual artist. I paint and draw, but also make sculptures and installations. My work, I want it to resonate really deeply on lots of levels with what's going on. So finding out about the science, I think, is really crucial.
My name is Caterina and I'm an independent dancer. My main dance form is contact improvisation, and I'm particularly interested in embodiment, and that's my approach to understanding climate change and relating to the topic and the people involved in that, so that I can convey the meaning through my body and through my own responses.
So I'm Catherine, and I am a visual artist, primarily working in painting and drawing, and am passionately interested, I guess, in the natural world without much of a scientific background in it. So I'm very interested in learning as much as I can.
Hey, I'm Paula, and I'm currently with FAST doing a PhD project on, it began as I was exploring kinesthesia, a felt sense of movement, and it's kind of evolving, and I've got a big focus on embodiment as well. And I guess what I'm finding relevant so far here is increasingly I'm working with a kind of dynamic systems approach and looking at bodily situatedness within its deep self and environmental self. Yeah.
And so a model that we make is you're making a representation of the natural world. And so you want this to understand connections between things, so you might be looking at a whole bunch of different species and you want to extract the connections between them, or you might want to make a prediction into the future. But the idea is to pull out information and capture that. So there was a study that came out, I think it was last year, and so what they did in this was they got a whole bunch of people doing science at different parts of your career, and these people doing brain science, and asked them to sketch what a neuron looks like. So here's a really interesting example of when they get asked to draw, this is what they start studying. So at the far left here, you start out with what the textbook says a neuron looks like, and it's got all the parts labelled in great detail. It's a technical drawing, extremely high. When you look through the microscope, they don't all look like this because this is an idealised form. So as you first start to learn about it, the pictures that people draw look a lot like the ones from the textbook. As you understand more and more, you start to throw away all of the bits of information that aren't important because you're trying to get at some fundamental part of it. You're not describing the whole system. And that's because if you describe the whole system, you sort of lose the wood for the trees kind of type of thing. If you look right up here at the far right-hand side, these incredibly abstract pictures of what's going on are from different different professors, and so they've got their different lines of research and their own hypotheses about what's going on. So a way that they think about it is completely removed from what you would see on that end. And so in some ways, this is a bit like going from classical art to modern art, where you are trying to get rid of all of the stuff that's not important and to get across the story and the narrative and the understanding. And so there's a quote here from a big name in stats. And so this is kind of getting the truth thing, where what he's saying is that no matter how good job you do, it's not going to be the true thing, because if you really wanted to see the true thing, just go and get one. Don't bother modelling it. So this slavish reproduction of nature is not what you strive for. And that whatever you do is not going to fit up to reality. But what you can hope for is that your approximation, your representation is useful in some way. And so what we should be striving for when we produce these things is something useful that you can take away.